Hello, my name is Alejandro Crespo. I study electrical mechanical engineering. My topic is about radio frequency accelerate the move away from mechanically steered antennas. The radio frequency electromagnetic waves are transmitted by applying the alternating current originated in a generator to antenna. Industries such as aerospace, communications, automotive, and defense are looking to move away from mechanically steered antennas for radar and communications connectivity. I present videos in relation to the topic.
Hi, my name is Eamon Nash. I'm an applications engineer at Analog Devices, and today I'd like to talk to you about Analog Devices' new XKU band analog beamformer IC ADAR1000. ADAR1000 is a 4-channel vector modulator designed for use in XKU band phased array applications. From a common RF feed point, the phase and gain of 4 channels can be independently controlled over a 31 dB range with a phase step resolution of 2.8 degrees. In our demo, we have 8 ADAR1000 devices across 2 boards, controlling the relative phase of 32 antennas. By simply turning the knob, we can adjust the relative phase of the channels and thereby steer the beam, which is being picked up by these RSSI antenna detectors. In addition to the 4 vector modulator channels, the ADAR1000 IC also includes on-chip DACs for LNA and PA bias, along with fast QR switch control outputs and a number of other valuable auxiliary functions. ADAR1000 is in mass production now. For more information, please go to analog.com/ADAR1000.
For efficient transfer of energy, the impedance of the radio, the antenna, and the transmission line connecting the radio to the antenna must be the same. Therefore, radio frequency energy is focused in a specific direction.
IMS 2017 in Hawaii. We are in the Analog Devices booth, and we are looking at a demonstration of phased array antennas. And you can see these LEDs over here, and they go up and down. They light up depending on where the beam is being steered.
All right, so I'm Pete DeLoss with Analog Devices in Greensboro, North Carolina. So we're demonstrating some of our analog beamforming ICs that are being released. They're 4-channel transmit and receive, X-band, 8.5 gig up to about 15 gigahertz. And our demo here, this is our eval board, common input, transmit and receive outputs here. And the demo has 2 evaluation boards. We have a common input to 2 4-to-1 analog beamformers, to 8 outputs to a line array antenna, and then we're electronically steering the beam, and our display is a series of antennas to power detectors to a display, so the display is an indicator of RF energy in that direction, and we're steering the beam across angularly.
Okay, from left to right.
Yes.
Okay.
And that's being done by controlling the phase shifts in our beamforming ICs.
Okay, and I can see as it's moving, you can see the LEDs light up and they get taller, and you can see right over there. So that should be coming along any moment. Yeah, you can see it starting to pick up. Okay. How many beams are you actually sending?
At this point, just one. So
Just one, okay.
There's a lot of dynamic range in here. It's actually 50 dB dynamic range, so you can see all the side lobes. So when the beam's over here, you can see the side lobe energy out in this direction.
I see. Okay, great. Thank you.
Digital beamforming represents as question STEM in antenna performance and complexity. The approach preserves the total information available at the production. This, coupled with the digital processing, offers tremendous flexibility. Beamforming basics digital beamforming, waveform generator and receiver channels, digital up-down conversion, converse, analog up-down conversion, analog beamforming, TR models, antenna elements.
Hi, my name is Mike Jones and I'm a Principal Electrical Design Engineer for Analog Devices. Today at IMS 2018 we are demonstrating an X-band phased array prototype, the backbone of which is the ADRV 9009 newly released transceiver. This ADRV 9009 allows us to have 2 transmitters and 2 receives per IC. When we combine all 4 of these, we're able to achieve 8 transmitters and 8 receives, as well as internal LO generation. They also have synchronization features for the RF-PLL phase sync and the JESD phase sync over multiple chip sync. Using all of these features, we're able to then build an L and S band solution if you need to stop there. If you need an X band or KU band solution, then you can use this type of up-down converter block architecture, which has mixers and amplifiers and filters. Finally, using our also newly released ADAR 1000 core chip, we're able to take these 1 to 4 outputs and then go through these TR modules to ultimately get to our phased array. To learn more about this, please go to analog.com/ADEF.
Complexity and acquisition cost versus full cost of owner for functionality. Mechanical system or fixed system. Numerous failure points, complex maintenance costs, low acquisition cost with low capability, single function and single frequency, comparable with legacy system, not for compatible. And phase array, limited failure models, requires little maintenance, functionality can replace multiple single function systems, provides multiple beams and multiple frequency capabilities, but towards compatibility with legacy, easy to upgrade and support, high acquisition cost, low lifetime cost. Applications in electrical, mechanical, sense and measurement equipment and facilities, the bandwidth of the latest radar technology for exceeded capabilities of commercially available test and measurement equipment. Although there are expensive and highly customized test systems, includes ENC facilities, vibration tables, environmental cameras, and near-far field test ranges. Pros and cons. Pros: simple design, well understood system infrastructure, flexible in operations, large spectrum coverage. And cons: susceptible to jamming, blocking, falling complex multiple, limited resolutions, and most specific design. Issue in applied and Equator. At the moment in Ecuador, this radio frequency technology has not been applied, but there are various of problems in which this method could be applied. Steering from the essential area of telecommunications in order to improve your communication to the equipment to the obtain a high efficient in industries and others. As a conclusion, it has this generation of his systems provide an order of magnitude with very reliability, but of equal importance is the special and capability to use multiple beams and spectrum. The last 5 years has seen development that made the staggered meters available to all the markers. When compared to the total cost of ownership, functionality phase array is becoming the preferred investment. Thanks for your attention.